Hello again everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video I'll do this combined science 5129 tutorial. This is not a lecture tutorial, this is a tutorial. So basically it's problem solving through some of the work that is associated with whatever that had been covered in the lecture tutorial on ionic bonding. So in those lecture tutorials, I covered the underlying concepts as well as what the syllabus expect you to be able to do. Just to recap what we have done, ionic bond is an electrostatic force of attraction. So you need to focus on this thing called electrostatic force. So there's the idea of bonding really. So it's an electrostatic force of attraction. The question is, it's between what and what? For ionic bonding, ions are charged particle, so it's between positive ions, which has got a name, is called cations, and also it's between positive and negative ions, because positive and negative ions are attracted towards each other, and you have this very strong electrostatic force of attraction. That is basically the full definition of ionic bond, which is strong electrostatic force attraction between positive ions called cations and negative ions called anions. As a result, the compound that you form is called ionic compound. Ionic compound is a compound. A compound is uncharged. Whether you're ionic compound or not, a compound does not have overall charge, but ionic compound consists of positive ions and negative ions, of which then the charges must cancel out to give you overall zero charge. So the process involved in forming ionic bond, you transfer electrons from metals to nonmetals. That is because metal lose electrons, therefore you form positive ions called cations. Metals are on the left side of the periodic table, so it's an overgeneralization, but group 1 and group 2 are definitely metals. They form positively charged cations after you lose the electrons. As for nonmetals, nonmetal atoms prefer to gain electrons, and when they gain electrons which are negatively charged, as part of your atomic structure topic, you can find out more in those topical playlists on the 5129 combined science or whatever other combined science syllabus with the IGCSE as well, on atomic structure specifically. So without further ado, let's actually apply what we have covered into actual examples. So NaCl, Na is a metal, so I hope you can realize that it's a group 1 metal. And then you also have Cl, which is a group 7 nonmetal. When you have bonding between a metal and a nonmetal, so what you have then is what you call an ionic compound. Okay, so this is sodium chloride. Group 1 metal is a metal. Metal lose electrons and form cations. If you are group 1, group number tells you how many outer shell electrons you have. Group 1 has 1 outer shell electron. When you lose the 1 valence electrons, you will get a fully filled outer shell, and that is why sodium, initially you started with 281. Initially you started with 281 because 2 in the first shell, 8 in the second shell, and then 1 in the third shell. But this is sodium atom. What you want is a Na plus ion. You want a Na plus ion, which is a cation, and you want a Cl minus, which is a anion. Alright, so what we're going to do is we're going to lose the 1 outer shell electron, so we are going to lose these. So meaning you are now having a fully filled outer shell, and that is a result of you losing 1 electron. That's why it's plus 1, and that's why a lot of books, they don't show as plus 1, they simply show as plus, because when they don't show the number, it means it's 1. Any other number they will show as plus 2 or plus 3 or whatever. But when they don't show it, it means it's plus 1, because you form it after the sodium loses the 1 outer shell electrons. Where does this electron goes to? So it goes to the nonmetal, which gain electrons. Chlorine is a third period element, so it comes in the third row of the periodic table. So that's why I'm drawing 3 shells, and I have 2 electrons in the first shell, 8 electrons in the second shell, and then I'm a group 7 element, so I have 7 electrons. I have done something wrong. So I don't want to put crosses, because crosses were what I used to represent the electrons from sodium. So I really should be using dot. That's why this kind of diagram I call dot and cross, because you want to differentiate, you want to tell apart, you want to distinguish the difference between the electrons coming from the donor, meaning the one which donates or give away, as well as the electrons from the acceptor, such as the non-metal here, which gain the electrons. So you got 2, 8, 7. 1, 2, 3, 4, 5, 6, 7. Group 7 non-metal has 7 outer shell electrons because group 7. So it received one of these crosses, and then you gain electrons. That's why you have a negative charge. You gain 1 electron, 1 crosses from the sodium atom. That's why you get a -1 charge, which will just write as -1. Altogether, hope you can see the +1 cancel the -1, and therefore the formula of sodium chloride is just Na plus Cl minus, 1 of each. You're gonna get NaCl, just like that. So in this next example on magnesium oxide, magnesium is a group 2 metal. It's in period 3. Oxide is an ion, so oxide ion is equal to ion of oxygen. Oxygen is a non-metal, and non-metal gain electrons in order to get to a fully filled outer shell. By the way, it's a group 6 metal, so it's period 2, group 6. Therefore, it will gain 2 electrons. And you will get O2 minus anion. Group 2 metal loses the 2 valence electron. Valence meaning 2 electrons in the outermost shell. As you know that from that first 20 electronic configuration from the atomic structure topic. So it loses 2 valence electrons. And as a result, when you lose electrons, you form cations, which are positively charged ion, and you form a 2+ charged cation because you lose 2 valence electron. So now let's try and put this into perspective. So magnesium, originally the atom consists of 3 shells because you are a period 3 element. So I'm going to draw the atom first, which I'm using a cross. So this is a 2 dot at, well, 2, 8, 2, 2 electrons in the first shell, 8 electrons in the second shell, 2 electrons in the third shell, is in period 3, group 2, 2 valence electrons there. Now, I lose 2 valence electron. I lost these 2 electrons in the third and the valence shell, so I'm going to remove that. Now I have a fully filled, I don't want to remove that. Now I have a fully filled outer shell, and don't forget that it's no longer an atom because you lost 2 valence electrons. Now you form a positively charged ion called cation. This is a Mg2+ cation. And what do we have on the oxygen right now? The oxygen, if I use a different things, let's use a dot. So 2 electrons in the first shell, and then oxygen is a period 2 element, and it's a group 6 in period 2. So 6 dot originally. But then it's 2 electrons short of 8 because fully filled second shell is 8 electrons. So this is 2, 4, and 6. It's a group 6 element in period 2. So it's got 2 shells, 2, 6, and there is incompletely filled second shell. This atom just now loses 2 electrons. The 2 electrons can easily go here, and that is why we can draw 2 crosses. We don't show 8 dots, we show 6 dots for the original 6 electrons. And now, we have 8 because we already gained 2 extra electrons there. And now we no longer have oxygen atom. What we have is oxygen ion. It's got a negative charge because you gain electron. it's got a 2 minus charge because you're gaining 2 electrons, and now the oxygen has a fully filled outer shell of 2,8. Now, how does the charges balance out? One of these is a +2, one of these is a -2. So your overall charge, how many do you have? You have a +2, you have one of the +2, and how many of the -2 do you have? You have one of the -2. You add them up together. So when you add them up together, plus times minus is a minus, so it's -2. This is 0. Ionic compound has no charge. So what we actually have is, we have Mg2 plus one of them, we have O2 minus one of them. They simply are written as MgO, one magnesium, one oxygen. What you don't see from this formula is they are ionic, and that's something you need to appreciate based on what you know about metal and a non-metal. When they combine together to form a compound, they form ionic bond. Okay. Onto this next one. So we have calcium chloride. This is a slightly tricky one if you look at it. Why is it 1 calcium and 2 chloride? Well, we got to think about it, because calcium is in group 2, so it forms a calcium 2 plus ion, just like magnesium was in group 2, it forms an Mg2 plus ion. Chlorine atom is from group 7, therefore it just needs to gain 1 electron. So this is the -1. So essentially I need to draw one of these, and I need to draw 2 of these, and hopefully you can see without drawing that -1 overall equal to -2, because -1 give you -2, and one of these give you +2. +2 here, you need 2 of these -1 in order to give you -2. +2 -2, overall 0 charge, just like the previous compound. But then here you just need 1 oxygen atom in order to gain both the electrons, so you get O2 minus. But Cl cannot form Cl2 minus because you just want a fully filled outer shell, 7 electrons in the outer shell, 7 valence electron because chlorine is in group 7, oxygen is in group 6, it's got 6 valence electrons there. So what we're going to do is we are going to draw for calcium. Calcium is in period 4, so it's got 4 shells, and all the inner shell, the first, second and third, is basically fully filled. So if I draw 2, 8, and then 8, and then I'll have 2 electrons in the fourth and the valence shell, so it's 2, 8, 8, 2. But this is calcium 2 plus, meaning to say I lost both my outer shell electrons, so I'm going to remove that. I'm going to remove that. Oops, I don't want to remove the 8. So I still have the third shell, but this is not a calcium atom anymore. This is called calcium ion, Ca2 plus. After you lost 2 of your outer shell electrons, you get a fully filled outer shell. What about the chloride? Chlorine is a third period element, is in group 7. So you can draw 3 circles as well to represent the, oops, I don't want that. To represent the 3 different shells. They are occupied with electrons. These are concepts that was previously covered under atomic structure and electronic configuration. I use dots here to represent the electrons for chlorine in order to try and differentiate, distinguish, to tell apart which electron come from which atom. So I have 7 of these dots because chlorine is in group 7, so it's 2, 8, 7. Remember, we lost 2 electrons. This cannot gain 2 electrons because 7 plus 2 will be more than 8. It will be more than the capacity. So I can just gain 1. If I gain 1 electrons, then that becomes Cl minus, and it's got 8 electrons in the outer shell, so it's no longer 2 at 7, it becomes 2 at 8, so it's nice and happy there. But as you could see, this gave away 2 electrons, only one of the 2 crosses are accounted for. So what you can do is, you need to another chloride ion in order to accept the other crosses. As you could see, there were 2 crosses being given away, 2 electrons being lost. This one gained 1 electron because 7 plus 1 equal to 8 fully filled outer shell electrons. 7 of these dots plus 1 cross give you 8 electrons in the outer shell. You need 1 of the plus 2, you need 2 of the minus 1, hence you have calcium chloride. 1 of the calcium 2 plus and 2 of the Cl minus, you end up with calcium chloride. This is the formula of calcium chloride. Makes sense from the dot and cross in terms of the transfer of electrons and counting how many electrons you need in order to get to a fully outer shell. Metals lose electrons to form cations, non-metal gain electrons to form anions to get to a fully filled outer shell. So moving on to the next part of this work, so this Na2O, so it's got 2 of the Na plus. The only reason I know it's Na plus is because sodium is a group 1 metal. They lose 1 of the outer shell electrons to give you a cation of plus 1 charge. The number at the bottom refer to the element before it. It means there are 2 of the Na, and then there's only 1 of the oxygen, and this is the non-metal. A group 6 non-metal gain 2 electrons, so they form O2 minus anion. So the oxygen atom is group 6, it gains 2 electrons. Whereas the Na atom loses 1 electrons because you only have 1 valence electrons to begin with. So at the end of the day, we are going to draw the Na plus. After you lose the outer shell electrons, previously sodium would have been 281. First shell, second shell, third shell, you lose the outer shell electrons, you are left with just 8 electrons in the outer shell. You say it's a plus 1. I need 2 of the plus 1. So what I can do is I can just copy paste it. It's easily done on my screen here. Each of these is a plus 1. This has lost 1 electron from the atom. If I have 2 of them, I lost 2 electrons total. And now the oxygen originally, the oxygen atom is a group 6 element, so it's 2, 6, first shell, second shell. So the second shell has 6 electrons. So I've got 2 dots in the first shell, and I've got 6 dots in the second shell. So 6 electrons in the second shell. To get to a fully filled, I need 2 more electrons. I gained the first one from the first sodium atom, but it only gave me 1 electrons. I'm still 1 short, so I need another sodium atom to give me another electrons. Altogether, I will have 2 Na plus ion and 1 of the O2 minus anion, because I gain 2 electrons. Group 6 non-metal gain 2 electrons. Group 1 metal lose 1 electrons. Altogether, I have, well, this formula, which you can simplify to Na2O. You don't see the ions, but you know it's ionic because it's between a metal and a non-metal. Finally, in these last questions, I'll go through, this is something rather simple, but lithium, if you look at lithium atom, it's not as simple as you think. So it's got 2 shells and it's in group 1. So it's just 2, 1. After you lose the outer shell electrons, what are you left with? You're left with just 2 electrons in the first shell. So it's Li plus now with only 2 electrons, which means it's completely filled because the first shell can only fill in 2 electrons maximum. Where does that 1 electron go to? It goes to fluorine. Fluorine is a group 17 atom, and therefore 7 plus 1, it will gain 1 electrons. It will form anion. It will form a minus 1 charge anion. So, not Cl minus, but it will form F minus. So it's got, I don't want to use cross because I need to tell apart the difference. So I should have, it's not always a cross for the metal. You could use dot for the metal and you could use cross for the non-metal. It just needs to be different. So originally I have 7 electrons in the outer shell because originally it would have been 2, 7, meaning to say 7 electrons in the second shell because it's group 7. And then I would have gain 1 extra electron from the lithium ion, from the lithium atom that give away the 1 electrons. Now you have Li plus. You gain the 1 electron from the lithium. Now you count minus 1 charge. Li plus, the charge is plus 1. F minus, the charge is -1. So overall, I hope you can see when you have 1 and 1 of them, you just condense down the formula to lithium fluoride, which is LiF. Group 1 metal loses 1 electron. Group 7 non-metal gain 1 electron. 1:1. So the simple formula is just like that. When you think about NaCl, group 1 metal, group 7 non-metal is also 1:1. Na plus, you got 1 of it. Cl minus, you got 1 of it. Overall charge of 0. Li plus, you got 1 of it. F minus, you got 1 of it. Overall charge +1 and -1, you get 0 charge. Okay. So I'll talk more about this crisscross method in terms of getting the formula in probably the next lecture tutorials on well, the lecture tutorial itself is the lesson, and it will make more sense by that time. Okay, thank you for watching, and don't forget to click the button on the bottom right to subscribe to my YouTube channel. There's ptet.chemistry. And yeah, follow me at ptet.chemistry on Instagram, Facebook, and Twitter. And yeah, share the channel widely with all your friends, chat and study groups, relative, juniors, seniors from school, whoever is doing the O Level Combined Science 5129, or whoever is doing the IGCSE Combined Science curriculum. Thank you for watching. See you in the next tutorial video.